DeMorgan's theorem. So DeMorgan's theorem says a plus b whole bar equal to a bar into b bar, or ab whole bar equal to a bar plus b bar. Simply you are just converting plus sign into sign. Plus means or into and, or replace and with or, you are getting the RHS. So here we are just proving it, this LHS equal to RHS, by taking the truth table. So because A, B, two variables are there, so there are 4 possible combinations. That is 0, 0, 0, 1, 1, 0 and 1, 1. Now first of all you will find out the values of A plus B. Now you are having a set of 4 combinations. Now you will put A plus B. A plus B is simply 0 plus 0, 0 plus 1, 1 plus 0 and 1 plus 1. Just putting a OR gate, you are getting the values of A plus B. Now the next step is you have to find out A plus B whole bar. Now in A plus B whole bar you have to take the complemented form of the things. If it is 0, complement says 1. If it is 1, complement says 0. Okay, just write the complemented form in this column. Now our LHS side is complete. Now we will work on the RHS. RHS says A bar into B bar. Now come to the column of A, where we have taken the values 0, 0, 1, 1. Now in A bar it will become 1, 1, 0, 0. And in B bar it will become 1, 0, 1, 0. Okay. So A bar into B bar will become 1, 0, 0 and 0. This is what we are getting when we are doing A plus B whole bar. So this is the case. A plus B whole bar equal to A bar into B bar. And this is the DeMorgan's theorem. X plus Y whole bar equal to X bar into Y bar. Okay. Now come to the second part, that is AB whole bar equal to A bar plus B bar. For AB whole bar we have to take the values of A and B. Then we have to find out AB and then we have to take AB whole bar. Because A and B, two variables are involved, so we will take the 4 possible combinations. Here 4 possible combinations are 0, 0, 0, 1, 1, 0 and 1, 1. Okay. So AB, just multiplying is 0 with 0, it is 0, 0, 1 is 0, 1, 0 is 0 and 1, 1 is 1. Just we are putting the AND gate laws and filling this column. Now next we want is AB bar. AB bar is just opposite of 0 is 1 and 1 is 0. Just putting the same thing over here and you are getting this column. Now this is the LHS part. Now we have to prove the RHS part over here. If A is 0, 0, 1, 1, so A bar is 1, 1, 0, 0. Similarly, if I am having B is 0, 1, 0, 1, I will have the B bar 1, 0, 1, 0. Now I have to prove it A bar plus B bar. Again you can put the OR law, means OR logic gate says 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 0 is 0. So AB whole bar equal to A bar plus B bar. So this is the case. So A plus B whole bar is equal to A bar into B bar and AB whole bar equal to A bar plus B bar. This is the very important theorem in the Boolean algebra and you will use this theorem again and again while solving the equations. Okay, let's move toward the next thing. Now prove this question, that AB whole bar plus AB and the whole bar is equal to 0. Now see AB whole bar. AB whole bar is, now we have to put the DeMorgan's theorem. And DeMorgan's theorem says xy whole bar equal to x bar plus y bar. Means AB whole bar equal to A bar plus B bar. So I am just opening this thing. It is A bar plus B bar. Means it is, we are using the DeMorgan's theorem. Here I have written over also. So plus A bar plus AB. Now because A bar twice it is coming and we know that when you are adding two numbers means A plus A equal to A. So A bar plus A bar equal to A bar. B plus B equal to B. Y plus Y equal to Y. So it is A bar plus A bar equal to A bar. If you are again adding same number again and again, you are getting the same number. So it is A bar plus B bar plus AB. Now Again putting the formula says a bar plus ab is equal to a plus b. We have already proved it. A bar plus ab equal to a plus b. A plus a bar b equal to a plus b. So what we will do, the number we are having will become a plus b bar. Okay, because you are having a bar plus ab, so you can convert it as a bar plus b bar plus a. Now you are having a bar plus a. Now a bar plus a is equal to 1. So it is 1 plus b bar. And we know that 1 plus something is equal to 1. So 1 complement equal to 0. That's why it is 0. So it is the case. So DeMorgan's theorem, as we have proved earlier also, that DeMorgan's theorem is same we have implemented over here. So here we are taking a bar plus b bar plus ab, then we are using the formula, then you are getting the answers plus 1, then plus 1 is the same value, means 1 will be there, and complemented form is 0, that's why it is 0. After that, next is reduce it. Again we will apply the DeMorgan's theorem here, because question is a plus b into c plus de bar whole bar. Now first of all solve it. De bar will become d bar plus e bar, so it will become c plus d bar plus e bar whole bar. Now again you have to put the DeMorgan's law. DeMorgan's law says x plus y plus z whole bar equal to x bar into y bar into z bar. Okay, so it will be c bar into d into e, a plus b c bar de. So it becomes a plus b c bar de. Okay, this is the solution. Because it is difficult to solve further, because here no other term is there. Otherwise you can go further also into, you can do a into 1. So 1 you can take with c plus c bar, then you can take again common c bar, and you can keep on going again and again. That's why what I have told you earlier in the starting of the lecture also, that in Boolean expression it's up to the candidate, it's up to the student, that up to which level he or she is taking the question to the level. Because it's up to me or up to the person who is solving it, that whether to end the question over here or take the question further, unless until LHS equal to RHS questions are there. Now you will see that here so many XOR gates, so many NOT gates were there, but here a simplest form is there, a plus b c bar de, means one we require NOT gate for c and then OR, because otherwise moreover AND will be there for b c bar de. But here you will see that you have to take a DE, then you have to take the complement form, then you have to add with C, then again a complement form. It will little bit a complex question. Let's move further to the next question. It is simplify a b bar c plus bd plus a bar b bar into c. Let's see how to solve it. Okay. First of all, what we can do is, because we are having c plus bd with us with a bracket. Now we will open the bracket. So it will become a b bar c plus a b bar bd plus a bar b bar into c. Then come to the formula that a number multiplied by its complement form is equal to 0. If it is 0, means this term is finished, vanished. So we are left with a b bar c plus 0 plus a bar b bar into c. Why 0? Because it is having the b and complemented form of b in terms of AND gate. So b into b bar, it is 0, so it is 0. Now it is a b bar c plus a bar b bar into c. Now again open the bracket. So it will become a b bar c into c plus a bar b bar c. Now we know that a into a equal to a, b into b is equal to b, c into c is equal to c. So it will become a b bar c plus a bar b bar c. Okay. Now let us see whether there is any common term present in between these two terms. See, it is a b bar c plus a bar b bar c. Okay, we can take a b bar c common. So I am taking the b bar c common term. Now it is remaining a plus a bar. And we all know that a term plus the complementary term is equal to 1. That's why it is b bar c into 1. So it is b bar c. I am repeating the same thing again. That question was a b bar c plus bd plus a bar b bar into c. First of all, open the brackets. When you are just opening the brackets, you will see that many terms are in repetitive mode or in complementary mode, just like A into A bar or B into B bar or B plus B bar, anything. So whatsoever you are getting a number into complemented form, just put it 0, because rule says A into A bar equal to 0 and A plus A bar equal to 1. Just after putting the values, you are getting the reduced form. And you can easily judge that this question is involved so many gates, but at last we are having only 2 gates. One is NOT gate, just for the B into B bar, and second is the AND gate for dot sign. Nothing else. It is B bar C. And this expression will take so many gates. If many gates are there, each and every gate is no doubt costly also and make the circuit more complex. Because actually wires make the circuit complex. As many as wires are increasing, the power dissipation keeps on increasing. Power consumption is increasing, and size, because the wires and gates will consume some area also. Because it is consuming the area, so it is making the circuit slow. So to make the circuit fast, we require the reduction of Boolean expressions.